Hello. Our objective today is that we are going to find the average value of a function on a closed interval using a formula. This is the formula for it. And before we get into to the actual questions, I just want to show you the connection of why this kind of works. Using the fundamental theorem of calculus, this integral would be equal to capital F of b minus capital F of a. So you would take the antiderivative of the function, and then you would plug in your upper and lower limits. And notice what happens. If you have a fraction 1 minus b over a out front times this, that would go to the numerator, and this would become capital F of b minus capital F of a over b minus a. And if this looks familiar, it should. This is basically the slope formula, but instead of finding you the slope, it's going to find you the average over whatever value you're actually doing. So instead of the average slope, it'll be like the average of all the y values together. But it looks just like that slope formula, and that's not an accident. But the formula itself, very easy to remember. It's just a definite integral with this 1 over b minus a out front. That's what we're going to be using as we do these problems. First example we're going to do by hand is to find the average value of this function, 2x cubed minus 3 over this interval. So we're going to just set this up. 1 over b minus a, so that's 1 over 4 minus negative 1. Turn that into a 5 in a second. Integral from a to b, so negative 1 to 4, of that function. So 2x cubed minus 3 dx. This should be a very straightforward problem. It's basically stuff you've been doing for a while, except it's got this fraction out front, but that's really fine. We'll just leave that out front the whole time. So this is 1/5, and then I'm going to put parentheses here, and we've got, let's see, integral of 2x to the third is 1/2 x to the fourth minus 3x from negative 1 to 4. I personally like to leave the 1/5 out the entire time until the very end. Just makes it a little bit easier, in my opinion. So when we do that, I'm just going to plug in this 4. Let's see, 4 to the fourth. I'm grabbing my calculator here. I don't know all these. 4 to the fourth times 1/2 is 128, and then minus 3 times 4, so that's minus 12. Simplify that in a moment. Minus plugging in negative 1. Negative 1 is not too bad to plug in because it's almost as good as 1. 1 to the fourth, or negative 1 to the fourth is 1, and then this is going to become plus 3. So let's see, 128 minus 12 minus 3.5 divided, or times that 1/5. So I know you guys could hear me just doing it on the calculator. This ends up being 1/5 times 112.5. So the average value after you multiply it by 1/5 is 22.5. Again, what that means is that this function, the average y value from negative 1 to 4, the average y value, if you added them all together and divided by how many there were, is 22.5. Our next example is a word problem. The inside of a funnel has a circular cross-section. So you see this weird-looking funnel, kind of cone-like, but not quite a cone. The radius of the function, whoop, I must have typed this wrong. The radius is a function of height. So what that means is whatever the radius is dependent on what the height is at some point. And you can see that the radius is smaller when the height is lower. The radius is larger when the height is larger. And it follows this function, 1/20 3 plus h squared, where h is between 0 and 10. So that must mean 0 to 10 is as tall as this height gets. Both height and radius are measured in inches, and then it says find the average value of the radius of the funnel. So the whole funnel goes from 0 to 10 in terms of height, which means we are going to be taking the average radius is going to be 1 over 10 minus 0. Even though obviously that's going to be 1/10, I do want you to write 1 over 10 minus 0 just to show that you know that that's what's happening. This is the integral from 0 to 10 of that function, so 1/20 times 3 plus h squared dh. This is something you could do by hand. It's not the worst thing in the world, but we're going to do it on the calculator. So what this means is this is going to find us the average radius of this funnel on the entire thing. I'm grabbing my calculator to type this in. So 1/10 times, remember math 9 to do integrals, so from 0 to 10 over 1/20 times 3 plus h squared dh. And this comes out to 1.817. The only other thing I want you to notice here is to make sure you give units. What we just found was the average radius. The radius is measured in inches, so we want to make sure that we say that this is in inches. The reason I want you to be careful here is we've done problems like this before, average slope, and if this was the average slope of the radius, it would be in something like inches per second or inches of radius per inch of height or something like that. That's not this case. This is how many inches is the average amount of inches, and that's it, 1.817. So that is it. We are finding the average value of a function on a closed interval using the average value formula.